Hi, this is TJ Singh and I'm the SICK product specialist at EandM in Southern California. The objective of this video is to show you how SICK Safety Designer software is highly intuitive and works seamlessly with different safety components irrespective of the brand, and how easy it is to configure any device, any system on this platform. For my demo today, I have a couple of safety components for which I want to give a quick description of their benefit and usage, and then we can jump into the live software demo where I will take you step by step on how to configure a safety application. All right, the very first product that I have is a safety scanner, which is the NanoScan 3 from SICK. It is a high performance 2D LiDAR where you can configure different safety zones to monitor any kind of a safety hazard. What makes NanoScan 3 really special is the super compact size, which is in a height profile of just 3 inches, makes it a perfect fit for AGV applications where space is always a constraint. We also have 3 meters of protective range on it and 10 meters of a warning range. Along with that, we have various different variants to match the specification of your application. Secondly, now we have a light curtain, which is from the D-Tech 4 family of SICK light curtains. Usually used in access protection, point protection. And what makes this light curtain really special and unique is firstly, no blind zones on this height profile. And then we also have inbuilt lasers which help you with the alignment. Along with that, we have something called system plugs on them, which have a lot of different functionality, such as muting, smart box detection, and they also come with NFC, and that is all inbuilt on the hardware. The third component is a non-contact safety switch, which is the STR1. These are very commonly used for gate monitoring applications. The STR1 works on RFID technology that makes it super useful, where you can mount it very flexibly and you get high tolerance. And it also has multiple coding options which allow it to be tamper proof. And finally, we got the SICK Flexi Compact safety controller, which is basically a decentralized controller for seamless integration of multiple safety devices. This is really unique. Why? Because it is easy to configure with our standard safety designer platform. It has a bunch of I/O on board, and if you need more, then we also have external cards then you can attach to it. If you want to do Profinet, we also have a gateway for that. And that's all the components that I have for this demo. And then we jump into the software and create the configuration. Okay, so I have opened up the safety designer software, and on the right side you can see that I have a bunch of these safety devices that SICK offers, and the best part is we have the same programming platform. What I'm going to use in my demo is a Flexi Compact safety controller, and I know the model that I have here, so I'm going to press on apply. And once I do that, the programming window opens up, as you can see right here. Now, it's pretty straightforward here, and I'll stress again, it's a highly intuitive piece of software, and you will know why. So the very first thing you see in the overview is all the part numbers and all the hardware configurations. Next thing is the configuration page. Now, this is where you assign what communication gateways you might want to use. In my case, I do have a bunch of options such as Profinet, EtherCAT, CanOpen. I'm not using it, and I can also add more I/O to it if I want, but we're not going to use it right now. Next thing is the inputs and outputs. So now SICK has configured everything under this tab called Elements. Ultimately, what these are is just their graphical representation on the type of electrical input or output that the device expects, and all you're doing is just assigning it. So in my case, I know that I want to connect a safety scanner, so I can find that under my electrosensitive protective devices, and I can drive it here. Now it's visible, so I know I'm going to use a nano scan, and I'm going to put it on input 1 and 2. It's dual channel, and I also know that along with this input I am also going to use an output which I have connected to a relay. So I go here, and once I click on the tab, I have a bunch of output options. Now ultimately I have just connected a safety relay, so it can be represented by a robot output which is dual channel. If you remember from my introduction, I also have a bunch of different sensors that I'm going to connect in this software system, and I wanted to do something which is more seamless and easier to configure. So I used something called Flexi Loop, and at the bottom here you can see something called Flexi Loop, and all you gotta do is drag and drop it. So that's going to be on my input 1 and 3, and there's a test pulse to it as well. And on the left side you will see that automatically comes up. Now if I press on this, what this does is, these are small nodes that are pre-wired internally, and all you have to use is M12 standard connection cables, and saves you a lot of time when you want to create a system and do less of all the, saves you a lot of time. In the nodes, we have 4 options. So in my case I have a light curtain for which I need a OSSD 5-pin output, so which will be OSSD 5. I double click on it and you see it gets added on the configuration page. Next thing is going to be my non-contact safety switch, which is the same node. And lastly I have a e-stop with a reset, and those are electromechanical safety switches, so I'm using a 8-pin connection, so I use this node. And similar to how we configured the Flexi Compact, here also we have some elements and represented by these nice graphics. And I'm going to use a light curtain DTEC 4 here, and I can drag and drop it. Next thing is going to be my non-contact safety switch, and for that also I can just drag and drop it here. And lastly I have a e-stop with a reset button, and I can do drag and drop. Now you notice there I still have one output left here, and that is basically a LED lamp, and I can go to my outputs here and assign that on this particular pin, and that's it. Now I've assigned all the IOs on how the configuration is supposed to look like. Now you go to your hardware configuration again, press on that, and you will see the same window. Now this part is done. Once you create this IO configuration, next step is logic editor on the top, where I click right now, and this opens up this logic page. Now here also it is super simple. If you see on the right side, we have inputs, function blocks, and outputs. Now how I like to do it is I click on the inputs first. I know I have a nanoscan 3, which is the safety scanner, connected here. I bring it in my page. Then I know I have a Flexi Loop, which has those 3 outputs, which has, and then I have the Flexi Loop, which has 3 different devices connected to it. So I can drag and drop it here. And lastly, I also have one more input, right? The reset input, and I can always just rename it, but I can drag it here. If you want, you can. All right. So once you have all the inputs here, you can go to your outputs, and here also I have a lamp LED output, and then I have my safety relay output. Now how we do the configuration is simple. SICK has pre-created these function blocks, And if I open it up, the very first one is the Boolean style. Here we have the simple and, not, and or. So I'm going to use an and logic block here. Why? Because I have those 3 safety devices. I want them to be in safe state before the device is allowed to operate. And I wire it here. Next thing is the safety scanner, and that also has to be in safe mode. And if you notice, the orange turns yellow as soon as the safety configuration it expects from the inputs are validated. Now once this is validated, I would use another function block. For basic applications, we have something called a reset function block. Everything is pre-configured. Now, as you know, this single channel is my reset output input, and I can connect it here on the reset function block. And this output for my safety devices will also go in this reset function block, simply to tell the function block, hey, I need a reset, or the reset has been done already. Now, if let's say the reset was not done and is required, we can connect this reset required to the LED here. And lastly, if everything is good, ready to go, we can connect the output to the relay. And if you notice, this also turned yellow, which means the requirements were satisfied. Once you do that, you can also use a simulation mode on the top here. If I press on that, I can actually simulate what I just created step by step. If I press on this play button, as you can see, it started to play. Now I can force start my safety scanner. Let's say it's turned on, and I can also turn on the other safety devices, and it's basically recreating how the actual devices would function. So now everything is good. It's asking for a reset with the lamp LEDs turned on. So I would give it a reset, press and release, and you would see the robot turned on. And that's how simple it is. And now let me send this configuration to the actual hardware. So now I'm connected to the actual piece of hardware, and I've transferred the configuration, and you can see that these terminals are green now. And if I put like my hand in front of the safety scanner, it turns white and green again. So it's actually connected. And if I go to logic editor, that actually shows you what the hardware is actually doing right now. And now it's expecting a reset. So I press on the actual reset, and right there it started working. And if I put my hand through the light curtain, you will see it turn off. And if I take it out, it's going to expect again a reset, which is also shown in the software. So I press on that, and if I open, let's say, the door, and this RFID switch is off, again it's asking for a reset now, and I press the reset. Same way, if I go in front of the scanner, it cuts the output, and again as I move my hand out, it's going to ask for a reset. And that's how simple it was to configure all these safety devices on the Flexi Compact using Safety Designer. Thank you for watching this video. If you have any questions, feel free to reach out to me at the email provided on the screen. Thank you.